Alright guys, so real quick we want to talk about finding the derivative of an inverse function when the inverse function is not known. So of course in some instances we can say find the inverse function. You might be able to do that here, maybe not. Sometimes you can use algebra to find the inverse function using the few steps from algebra class. But it's better and quicker simply just to use what we call Theorem 3.17 out of our textbook. Again, Theorem 3.17 allows you to find the derivative of an inverse function when you do not know the function rule of the inverse function. Okay, so number 73 here says we want to find the derivative of f inverse at 11. Okay, so here's what Theorem 3.17 says. Theorem 3.17 says that f inverse, let's say f inverse prime of, not of x, let's say of 11 in this case, equals 1 divided by f prime of f inverse of 11. Okay, so this means we don't necessarily even need to know the equation for f inverse. All we need to know is what f inverse of 11 is. Now, you may say, well, how the heck are you going to do that without the equation of f inverse? And here's how you do it. We have to think about domain and range. Okay, so off to the side here, always do what I'm about to do. Always do this when you're solving these problems. So think about this. We have a function. We have the function f of x, and we have the function f inverse of x. Now, f of x, of course, has a domain and a range, and f inverse has a domain and a range. But remember, how are these things related? If there is a comma b in a point on the graph of f, we're guaranteed that on the graph of f inverse we're going to have the point b comma a. Okay, so that tells me that the domain and range of an inverse function are essentially swapped. Okay, so what I need to do, or for this particular question, what I need to know is what does 11 map to in the inverse function. Okay, so I need this right here. I need this value to go right here, but I don't know how to get it currently at the moment because I don't know the equation of the inverse function. If I knew the equation of the inverse function, we would just plug it in. But we don't have that equation, so we can't plug in. But here's the trick. If you know 11 is in the domain of the inverse function, 11 has to also be in the range of the regular function. So if 11 is in the domain of the inverse function, then 11 has to be in the range of the regular function. And now what I can do is simply solve this equation. 11 in the range of the original function means solve this equation for x to find the missing piece here. 11 equals x cubed plus 2x minus 1. Now, of course, if the answer was hard to get in this situation, we would have to do things like using maybe things like the remainder theorem and polynomial division, synthetic division, to find the answer here for x. That is, we have to factor it, set it equals 0 and factor it. But I think we can figure this answer out pretty easily by just testing out a few values. Like obviously 0 doesn't make this equation true. 1 doesn't make it true. 2, let's see, 2 cubed is 8 plus 2 times 2, so 8 plus 4 is 12, minus 1 equals 11. Yeah, so clearly, just by inspection here, x equals 2 x equals 2 is a solution here. Okay, let's erase that. X equals 2, okay? So that tells me that a 2 goes right here. But if a 2 goes right there, then automatically a 2 goes over there at that question mark. So a 2 goes there. And that's the key here, because now we're pretty much home free. Because what we can do is say, okay, this equals 1 divided by f prime. We know that f inverse of 11 is 2. So now all we have to do is figure out what f prime of 2 is. Well, okay, let's find f prime really fast. That shouldn't be too tough. F prime of x, okay, where's the original? Here's the original. The derivative of the original function f is 3x squared plus 2 plus 0. So 3x squared plus 2. So what is f prime of 2? F prime of 2 is 3 times 2 squared plus 2, which equals, okay, that's 2 squared is 4 times 3 is 12, is 14. So going back over here, the denominator here is simply 14. So there is our answer. Okay, so 1/14 is the slope of the inverse function at 11. Now, let's look at a picture to verify this. Oh, by the way, let me write a few things out here. So at what is the point? 11, 2 on f inverse of x. The slope is 1/14. Okay, the other side to that coin is that at 2, 11 on f of x, the slope is 14. That is, when you look at the corresponding point, that if you transpose the x and y values, then you can flip the slope. That is, just take the reciprocal. Not negative or anything, just take the reciprocal, and that's how this relationship plays out. Let's verify that with a picture. Let's see. Give me just a minute. Let's pull up Desmos. So there is the original function. Okay? There's the original function. Now I said that that original function at the point, oh, I forgot now. Let's double check. The original function should have a slope of 14 at 2, 11. So first of all, 2, 11 should be a point on that curve. And it looks like it is. Yeah, that's on the curve. And the slope of that line should be 14. Now let's just, we can write the equation of that line really easily using point slope form. Y minus y1, so y minus 11 equals m, which is the slope, times x minus x1. And there, notice, there is our tangent line. It's really steep, so it's kind of hard to tell, but there is clearly our tangent line at the point 2, 11. So here's the thing. Let's get our inverse function now. Now, I'm not going to actually solve for the inverse function like using those steps from algebra class. What I'm going to do is simply write the implicit version of our inverse function. So the regular function is y equals, oh, I just messed that up, is y equals x cubed plus 2x minus 1. If I write instead x equals y cubed plus 2y minus 1, I get my inverse function. Now, of course, it's not the explicitly defined inverse function, it's the implicitly defined inverse function, but there it is. So the orange is my inverse function. And what did we say? We said at the point, first of all, the point 11, 2 should be on there. Yes, it is, the purple point. And that the slope of that line should be 1 divided by 14. So let's again use point slope form to write the equation of the line. So y minus 2 equals 1/4 times x minus x1, which would be 11. And there is not the, oh, that's why, it's 1/14. There we go. So we have the tangent line at the point 11, 2 and 2, 11. Here's the original function is the red. The inverse function is the orange. And we have the black tangent line with a slope of 1/14 and the tangent line at the corresponding, I guess the transposed point on the original function. Okay, lastly, just to make this look nice, let's put the identity function in. Here, let's change the color. Let's give, I guess blue will work. And let's make it dotted. There, so notice how we have the identity. Let's turn the tangent lines off. See how the original function and the inverse function are clearly reflections across the identity function, this blue dotted line. The identity function, finally putting back our tangent lines. There we go. Okay, so just wrapping up, that is how we find the inverse, the derivative of an inverse function without ever knowing the explicit definition of the inverse function. If you're in our book, it's Theorem 3.17, super important theorem out of chapter 3. Hope this has been helpful. If you need more help, just let me know.